We're going to start this lesson by determining whether a function is even or odd, a little bit from the graph, but mostly algebraically here. So if you need to pause this and copy this down, please do so. I'm going to be talking about a lot of it, but I would recommend you not writing while I'm talking. So either pause and write everything down and then listen, or do it the other way and listen and then pause it and write everything down. First, if we go over even functions have y-axis symmetry. And in your notes from last lesson, we even noted that symmetry with respect to the y or even functions. And you can see here in this graph, we have y equals x squared. So x squared, we have an even exponent, and we do have something that is has symmetry with respect to that y-axis right there, right? The left side, here's the right side of that y-axis. Now, what even functions do technically is that opposite inputs are going to give me the same outputs. We wrote that in our notes last time that we said x comma y equals negative xy. So notice x, we have an opposite inputs, x and negative x, but either way we get the output of y. And you can see that right here in this. If we put in 3 into this equation, 3 squared is 9, so we get the 0.39. If I put in negative 3 in parentheses squared is negative 3 times negative 3, which is positive 9. So when I put in opposite inputs of 3 and negative 3, I still get the same output of 9. So what does that look like in function notation? If we input a negative x, then we need to get out the same y. F of x is just another name for y. Now coming over here to odd functions have origin symmetry. So if you can just remember O for odd, O for origin. And I have a diagram of something here. We have y equals x cubed. So cubed, odd, we have an odd function. And from our notes last time, we put that in here. Symmetry with respect to the origin or odd functions. And odd functions mean we can rotate this. Now, this isn't a perfect graph, but technically, if you rotate it, that should look the exact same. And this one has still opposite inputs like we had here, but now we're going to get in opposite outputs. Here we get same outputs. So when I put in 2 cubed gives me 8. When I put in the opposite input, negative 2, now I get the opposite output. Instead of having 8, it gives me negative 8. And that is again what we had here. We had x, y, and then negative x, negative y. Opposite inputs, x and negative x, give me opposite outputs, y and negative y. So again, in function notation, since we're still doing opposite inputs, that's f of negative x, but now we're going to get opposite output, so negative of my function. So I have put these in highlighted boxes. This is how we determine algebraically. Example 1 says determine algebraically whether the given functions are even, odd, or neither. So what we do, because both of them have to do with opposite inputs, we will put in an opposite input of negative x. If I get the original function, then it is even. If I get the opposite of this function, the negative function, then it is odd. If I don't get either of these outcomes, then it's a neither. So let's try. We have our f of x here. So I am going to substitute in here f of negative x. So everywhere I see an x, I am substituting in a negative x. So we get negative x to the 4th minus 2 times negative x squared plus 3. So if I clean that up a little bit and simplify, negative x in parentheses to the 4th. Negative times negative is positive. times negative is negative, times another negative is positive. So these two make a positive, these two make a positive, we have positive. So this is x to the fourth. If this is an even exponent, it's going to come out positively. If it's an odd exponent, it's going to come out negatively. So likewise, negative x squared is going to be positive times a negative 2 is negative 2x squared, and then bring down your plus 3. So I've substituted in my negative x, and now I have simplified. Because my negative x equals, this equals the original, my f of x, that means this function here is even. These are always the easiest to identify because it's a matching game. Does this match the original? If it does, it's even. Now moving on to b, we have g of x. So I'm going to plug in a g of negative x. And so everywhere I see an x, I'm putting in negative x. So we have 3 times negative x all over 4 times negative x squared plus 6. So simplify that. Positive times negative gives me a negative 3x all over negative x squared is positive times 4 is 4x squared. Bring down your plus 6. Now, if you can't tell from this form here, when we're talking about fractions, it doesn't matter where this negative go. So this negative can go on the top. This negative could have went down here at the bottom, or it can go outside and be more neutral. So this would be the same as negative 3x over 4x squared plus 6. Okay, so more of using this form here, I can see that when I plugged in a negative x, this is the exact same as this with that negative out front. I got negative g of x. So because when I plugged in a negative, I got the opposite of my function, that makes this odd. Last example, we have h of x, so I'm going to substitute in a negative x. So we have negative 7 times negative x cubed minus 5. And now clean it up. Negative x cubed is negative times negative 7 is a positive 7x cubed. Bring down your minus 5. This one here, when I substituted in a negative x, it did not equal my original. That one's very clear to tell. We have positive. It started off negative. We also did not have the negative version of f of x. For this to be the negative version, let me just bring a little sticky note in here. For it to be the negative of this, we would have negative 7x cubed minus 5. Negative times negative would be positive 7x cubed, which I do have. But the negative times negative would be positive 5, and I have a negative 5. So it is not the opposite. This would be negative h of x. So it does not equal the negative either. Because it does not equal either of these, that makes this one neither. Now again, telling whether or not this is even is the easiest. Does it match or does it not? What's a yes or a no? to help you understand what you have found out algebraically, you can use your graph to find these. So if I do this one here, okay, in my y equals, I'm going to put what my function was. So negative 7x cubed minus 5. And I don't know what graph we need, so I'm just going to do zoom 6 for a standard. That's always a great spot to start. Okay, and there's my graph. I'm going to change my window here just to make it hopefully a little bit more clear. Okay, so there is my function. I can tell it doesn't have even symmetry right from the get because that's y-axis symmetry. So does the left match the right? No, that does not look the same as that right there. So that's not y-axis symmetry. So is it origin symmetry? If you flip this upside down, no, that's not the same because this is squiggling up at the top now, and it was squiggling down at the bottom. So you need to put it in your graphing calculator to help you figure that out. If you are confused about the result you got here, put this one in. I'm going to use alpha y equals to give me a fraction. I've got 3x over 4x squared plus 6. Okay, not the best graph, so let's try a zoom 4 for a decimal. Let's see if that helps. Okay, that helps. You can clearly see that this does have origin symmetry. If we want to get in even closer, let's just move this y to -1 and 1. So it's crossing out that origin, and when I flip it upside down, that does look the exact same. So if I put this in my graph and kind of mess around with my window, I can see very clearly that this does have origin symmetry. So on your test, you're going to have to tell me, does it have even, is it an even function, an odd function, or neither? I need to be able to see you substituting in this negative x and simplifying it correctly. But if you need help figuring out what this is telling you and what this is telling you, put it in your graph to help you figure out, is that y-axis symmetry, origin symmetry, or neither?